Now, dual of Miller's theorem. So, dual of Miller's theorem states that if I have a shunt component or if I have a component common to input and output, like this, see, Z is present common to both input and output, right? So, I can split this Z separately for input. I can split this Z separately for output. Okay, that is what is the dual of Miller's theorem. Okay. So what we have seen in the first case is if there is a component present between input and output, I can apply Miller's theorem. That is the first scenario of Miller's theorem. The second case is if I'm going to have an element common to both input and output side. See here Z is present in shunt, and if you apply KVL, this Z will come in the input loop, this Z will come in the output loop also. So Z has a presence in both the loops, so I can say Z is common to both input and output. In such a case, I can split this Z into two components, one in the series side, it is given by Zi, and one in the shunt side given by Z naught. And the formulas are same. Zi equal to Z into 1 minus AI, Z naught equal to Z into 1 minus 1 by AI. See, when you have element in series, in the previous case, I'll be using voltage gain. When I'm having element in shunt, I'll be using AI. AI is going to be the current gain. See, dual knowledge, everything will be completely opposite. Series la voltage gain, so I will be using AI. Shunt la it is current gain, so I will be using AI. Previous case I am going to use AV. Here I am going to use AI. And the formulas are same. Zi equal to Z into 1 minus AI at the input side, Z not equal to Z into 1 minus 1 by AI, or if you take LCM, Z into AI minus 1 by AI at the output side, where AI is going to be I2 by I1. So I2 by I1 is the current gain of your amplifier. So if uh, these two networks are identical. So if you apply KVL to this network or if you apply KVL to this network, you will find that the output voltage V2, whatever you find, it's going to be the same expression you will get before applying Miller's theorem or after applying Miller's theorem. Okay, so this Miller's theorem is used to simplify circuits. So whenever you have lot of parallel components in common to both the circuits, you can transform them into series components using